Hello, my name is Dylan Gallant, and this is my solution for our final set of coding problems for our final exam. If I sound a little weird, I apologize. I'm a bit under the weather. But we went ahead and finished the project anyway, because why not? Alright, so our very first problem is our string problem. What we're doing together is lacing two strings, where we are given a string A and a string B, and we need to go in and lace them together by putting one character for the first string, then one character for the second string, back and forth for as many strings as we have, and then if one has more strings than the other, then just putting all of those at the end. So A, B, C, D, and E, F, G, H, I should end up just like that. So my solution to that is right here. So we defined lace strings, and we put together string A and string B. We have our final solution right here, which is going to be laced string. I grabbed the lengths of string A and string B, and then my length C right here is length A plus B. And then for X in range length C, the reason I did this is so that we will always iterate at least as long as the longest string, so we don't have to check which one it is. We just add them together, and we know we're going to at least be that long. Then what we're going to do is we're going to check if length A is not 0. As long as it's not 0, then we're going to add to our laced string. We're going to add from string A whatever position we are. So, of course, if we're in the first position, we'll add the first character into laced string A, and then we'll come down and do the exact same thing for B. And after every time it iterates, we remove one from length A and one from length B, so that once we get to the end of either string, we don't keep looking. Once it does all of that, it prints it together, and of course, if we run it, A, B, C, D, E, F, G, H, I prints beautifully. Our next problem is prime number. Write a Python function that creates and returns a list of prime numbers between 2 and n, which is whatever number we give it. So how I did that, we have defined primes list, and n is right there. So we're just going to put together a list, which is eventually going to be our output. We're going to look in a range between 2 and n, because we can't have any lower numbers than 2 or lower prime numbers. As we have a Boolean variable right here, which is prime. For j, which is our second variable, which is going to let us iterate between whatever number we're currently looking at and everything below it. For j in range 2 and x. If j divisible remainder is equal to 0, that means the prime is false, because that means they divide evenly. So as long as everything keeps dividing with the remainder, then we know the number is prime. If it ever gets to 0, then we know it's not prime and it will break. And as long as it is prime, we're going to go to the prime list. We're going to append it with whatever number x is. Then down here, our number is equal to an integer, which is inputted. Please enter a number. And that runs beautifully just like this. So we'll just go ahead and give it a smaller number. We'll do 30. And that is every prime number between 2 and 30. Our next one is our dictionary problem. Given a dictionary that maps integer keys to integer values, write a Python function that returns a list of keys in a dictionary that map to dictionary values that appear exactly once in a dict. So how we do that is right here. So very first thing is we would just want to create a dictionary to count the occurrences of values in our adict right here. So we just have a value counts right there. Count the occurrence for each value. So for value in adict.values, if the value is n, value.counts, I'm just going to go ahead and just add the value add 1, else it's just going to be equal to 1. And then we're going to create a separate list right here just called results. And then for key and value in adict items, if value counts value right here is equal to 1, we're going to append the key. And then it just returns the sorted list right there. So if we do our dictionary like this, which is given to us right here, if we do That dictionary should be 138, and this one, since we only have the ones, should be nothing. Bing, bang, boom, runs beautifully. The U.S. resident problem. This problem, you will implement a class according to the specifications in the template, which we have. File contains person class, similar to what you have seen in lecture in a U.S. resident class, which is a subclass. Person is already implemented for you, and you'll have to implement two methods of U.S. resident. So right down here, obviously we don't have to implement anything in here. This is all for us, but if we look down to here, of course, this red line is going to be referenced right here. We'll show the value error was raised at a particular line. That was our value error. That's fine. But yeah, the first thing we do is we just initialize the name attribute from the person class right here. And then we're going to validate the status. So valid status equals citizen, legal resident, and illegal resident. If the status is not invalid statuses, then we'll just give the value error. And then we will just set the status attribute. So we just self.status is equal to status. And then right here is just a function just to get the status, and we just return self.status. So if we get A equals U.S. resident, Tim Beaver citizen, print A gets status, and then of course, yeah, should just print citizen, just like it says right here, and of course shows the value error. We can run that. Just like that. Of course, value error, but it prints citizen before that. And our final one is the container problem. So all this given to us for our container, we're going to write a class that implements specifications below. So all of that is right down here. Of course, all that's given. We'll look down here. So when we're looking at this, we are going to class A, set the container, of course, and then right here. So we're going to check if E exists in the dictionary and set its count to 0, which obviously just means we're just going to remove it. And then down here, of course, because we're removing because that's the definition. Right here, we're just going to check, is it in it? So we have self and E, and we're just going to return if the value gets this E, it's greater than 0, which means it's there. So we just return that. And then here we have all of the examples that were printed down here. So D1 is equal to A set. We're going to insert 4, and remove 2. If we print D1, it just gives us 4 and 2. And then D1 A set, insert 4, print D1. So this is just telling us, is it there? Of course it's true. Insert 5, is 5 in it? Of course it's true. Remove 5, is 5 in it? And that would be false. All given 4 and 2, and then true, true, false. That is my final exam. Thank you very, very much.